When we talk about programming, the term paradigm refers to a method or approach for solving problems using a programming language. Think of paradigms as strategies or methodologies that guide how we write and organize code. Python, being a versatile language, supports multiple paradigms, allowing developers to choose the best approach for their specific needs. In this video, we'll explore the three main programming paradigms supported by Python: object-oriented, procedural, and functional. Each paradigm offers unique tools and techniques, shaping how we structure our programs and tackle challenges. Understanding these paradigms not only broadens your programming perspective, but also helps you write more effective and maintainable code. Let's dive into each paradigm and see how they differ and where they shine. Object-oriented programming, or OOP, is a paradigm where objects are the central elements. In Python, objects are instances of classes, and they bundle together data and the methods that operate on that data. This approach supports key concepts like encapsulation, which keeps data safe within objects, and inheritance, which allows code reuse by letting new classes build upon existing ones. OOP is great for modeling real-world entities and relationships, making your code more intuitive and organized. However, it's not without drawbacks. If not structured carefully, OOP code can become complex and hard to manage. It may also be slower and not always suitable for every problem. Here's a simple example. Imagine a class called emp that stores employee details and a method to display them. Creating objects for each employee lets you manage their data efficiently. This style is especially useful in large, complex applications where structure and reusability are important. Procedural programming is all about breaking down tasks into a series of step-by-step instructions, organized into functions. In Python, this means writing code that executes in a specific order, with each function handling a distinct part of the process. This paradigm emphasizes modularity, making it easier to organize related code and reuse functions across different parts of your program. Procedural programming is especially effective for general-purpose tasks and when you need portable, straightforward code. However, it may not be ideal for representing complex real-world objects, and as programs grow, managing data protection can become challenging. For example, to find the sum of a list, you might write a function that loops through each value and adds them up. This approach is simple and direct, making it a solid choice for many everyday programming problems. Functional programming takes a different approach by focusing on pure mathematical functions and treating computation as the evaluation of expressions. In Python, this often involves using lambda functions and recursion. Functional programming is considered declarative, meaning you describe what you want to achieve rather than how to do it. This paradigm encourages writing code that is simple, easy to test, and highly readable, especially for mathematical or data transformation tasks. However, it can sometimes lead to lower performance and may be harder to write or read for complex problems. For instance, summing a list can be done using a recursive function or with the help of Python's functools, reduce, and a lambda expression. Functional programming is a powerful tool in your Python toolkit, especially when you need concise and expressive code.